Hey everyone. It seems like everywhere you turn lately, quantum computing is popping up. And for good reason, right? It really does have the potential to just completely change everything.
It really
It
does.
does, it does. But sometimes it can feel like a sci-fi movie, a little bit,
Oh,
right?
yeah.
We've been digging into all those articles you sent us on Microsoft's new Majorana 1 chip.
Yeah.
And trust me, this is not just another tech release. This
No.
is a deep dive to really understand what makes this different, why you should care, and maybe even uncover some possibilities you hadn't even thought of. Some mind-blowing possibilities,
Yeah, quantum computing has been kind of the next big thing for a while now.
right?
But it's always been hampered by these fundamental challenges.
Yeah.
And what's interesting about Majorana 1 is that it really seems to be tackling those head on, so it's potentially a game changer.
Okay, so let's jump right into it. One of the biggest hurdles with quantum computing so far has been just how delicate those qubits are. And qubits, as you probably know, are the building blocks of quantum computers.
Right.
They're super sensitive to any disturbance at all. It's like, imagine trying to build a house of cards in a hurricane.
Right. That's a good analogy.
That's what it's like working with these traditional qubits.
Yeah, even the tiniest change in temperature, or a little stray radiation,
Oh, yeah.
that can cause them to like lose their quantum state.
Oh, wow.
And that just leads to errors. It's like if you're trying to solve a complex equation
Right.
on a calculator that just keeps like spitting out wrong numbers.
Keeps messing up. Yeah, yeah. Okay, so this is where it gets really interesting and kind of mind-bending, right?
Right.
Enter the Majorana particle, a theoretical particle called a Majorana fermion. Now get this.
Yeah.
It's its own antiparticle.
That's a wild concept.
Right.
It is. Essentially, it's both matter and antimatter at the same time.
Wow.
So it's got this really paradoxical nature,
Right.
which is what gives them this stability that we don't see in traditional qubits.
So instead of just trying to isolate the qubits from all that environmental noise,
Right.
which is a really difficult and expensive task,
Yeah.
Microsoft went in a completely different direction.
Yeah.
Right. They're
Yeah.
trying to harness the properties of these Majorana particles to create what are called topological qubits.
Yeah.
Can you explain what those are exactly?
Sure. Think about a knot in a string.
Okay.
You can shake that string all you want, but the knot's going to stay put.
Right.
And that's because with the topological qubit, the information is encoded in the shape of the knot,
Hmm.
not the state of a single particle.
So that's why they're so much more resistant to all that noise?
Exactly. Yeah.
That messes with the traditional qubits.
Exactly. Yep.
But I'm curious, how did they even get their hands on these Majorana particles? Did they just, find them lying around somewhere?
Well, that's what's so fascinating. They actually engineered a brand new material
Oh, wow.
to absorb and control these particles. They call it a tokaconductor. And it's kind of a big deal. Think of it like discovering a whole new element on the periodic table,
Right.
but specifically for quantum computing.
Hold on. A brand new material? That's huge.
Yeah.
So they're not just trying to isolate these very sensitive qubits. They've actually created a whole new material to make them more stable.
Right.
Like they're building this custom-designed fortress.
Yeah, that's a great way to put it.
Right,
Yeah.
for these Majorana particles to thrive in.
And what that does is it makes Majorana 1 potentially a much more self-contained system.
Oh, interesting.
It reduces the need for all those complex external systems
Right.
that can cause more errors.
I see. Okay, so we're talking about a quantum computer that's not only potentially more powerful, but also potentially simpler to build and scale up.
Potentially, yeah.
And speaking of scaling up, Microsoft is not thinking small here.
No.
They're talking about putting 1,000,000 qubits on a single chip.
1,000,000. Wow, that's mind-blowing. To put that in perspective, some experts believe that kind of computational power
Yeah.
would be greater than all the computers on Earth combined today.
Oh my gosh. Okay.
Yeah.
So this is why everyone's so excited. We're not talking about just a slightly faster computer here. We're talking about the potential to solve problems that were previously impossible. So this is where it gets really interesting to me. What are some of the potential applications?
Well, I think before we jump into applications,
Yeah.
it's important to understand what this kind of computational power means.
Okay.
Practically, we're talking about being able to analyze incredibly complex systems to simulate processes that were previously just beyond our reach.
So not just faster calculations,
Right.
but a whole new way of approaching problems.
Exactly, yeah. So imagine being able to model the behavior of individual atoms in a material
Wow.
to design drugs at a molecular level,
Right.
or to create entirely new materials with properties that we can only dream of today.
Right. Okay, I'm starting to see the potential, so let's
Yeah.
get specific. One area that I always think is so interesting is material science. What could Majorana 1 do in that field?
Okay, so imagine a world with self-healing materials.
Oh, wow.
So your phone screen cracks, no problem, it just repairs itself.
No more cracked screens. Sign me up.
Right. Bridges, aircraft,
Yeah,
all sorts of structures could become incredibly resilient.
right.
We could create materials that are lighter, stronger, and way more durable than anything we have today.
So instead of fixing things that they break, we could actually design things that just won't break,
Right.
that are resistant to damage.
Yeah.
That's incredible.
Yeah.
But what about like going beyond just making things stronger? What about developing new materials with properties we haven't even thought of?
Yeah, that's where it gets really interesting.
Yeah,
We could design materials that are superconductive
right.
at room temperature,
Oh, wow.
revolutionizing how we transmit energy.
Wow.
We could create materials that, capture and store carbon dioxide from the atmosphere.
Right, combating climate change.
Exactly, yeah.
Wow. Okay, this is all pretty mind-blowing.
The possibilities are pretty much endless.
They are. But let's shift gears a little bit and talk about something a little closer to home, like healthcare. How could Majorana 1 change medicine?
Okay, well, think about drug discovery.
Okay,
Instead of spending years, billions of dollars developing new drugs,
right.
we could use Majorana 1 to simulate those molecular interactions,
Wow.
but at an incredible speed. And that could lead to personalized medicine,
Yeah,
faster cures for diseases like cancer.
right. So instead of trial and error,
Right.
you could just like design drugs that are targeted to an individual
Exactly.
based on their genetic makeup.
Yeah.
That's amazing. What about diseases that don't have treatments?
Yeah, we could use it to simulate the progression of a disease,
Oh, okay.
to identify potential drug targets, and then test new treatments in a virtual environment.
Oh, wow.
So it could really accelerate the whole drug development process
Okay.
and give hope to millions of people.
Yeah. This is starting to feel like a sci-fi movie.
It is, it is.
It's pretty incredible, yeah. But I think it's important to remember that this is all based on potential,
Right,
right?
right.
We're still in very early stages of development,
Yes.
and there's still a lot of challenges ahead.
Yeah, we need to be realistic about the timeline
Yeah.
and the hurdles.
Yeah,
But the progress that we're seeing is really encouraging.
it is.
And the possibilities, really are transformative.
Okay, I'm convinced that this is a game changer. But let's talk about access for a second.
Oh.
Who is going to be able to use this incredible technology? Is it just going to be big companies,
Yeah.
research institutions? I mean, who gets to use it?
Well, that's where things get really interesting. Microsoft is planning to make Majorana 1 available through the cloud.
Hold on, the cloud. You mean like I could access a quantum computer
Yeah?
from my laptop?
Well, not quite that simple. You wouldn't be directly controlling the hardware,
Right.
but you would be able to access its computational power
Okay.
through a cloud-based platform.
I see. I see.
So similar to how we use cloud computing today.
So it's like renting time on a supercomputer, but it's a quantum supercomputer.
Exactly. Yeah.
That's amazing. And they're developing like tools and platforms to make quantum programming more accessible, right?
Right, exactly. Even for those who, don't have a deep understanding of quantum mechanics.
So even if I'm not a quantum physical expert, I could still potentially like use this.
That's the goal.
Wow.
Yeah, and this potential for democratizing access
Yeah.
to quantum computing
Right.
is what makes this technology so transformative.
Right.
We're not just talking about a handful of institutions or corporations
Right.
having this power.
Yeah.
Potentially anyone with an internet connection could tap into it.
That's huge. So instead of, just a select few, it could be this global community of innovators all working together,
The exact.
pushing boundaries.
And that's what makes it so exciting. We're not just talking about these incremental improvements.
Yeah.
We're talking about a paradigm shift in how we approach, some of these big challenges
Yeah.
that are facing humanity.
Well, I am officially blown away, but let's be realistic.
Yeah.
Even with cloud access and these user-friendly tools, there's still going to be a learning curve,
Oh, absolutely. Yeah.
right? I mean, quantum computing is pretty specialized.
Yeah. There's no denying there are going to be challenges.
Right.
Quantum programming, it requires a whole new way of thinking.
Yeah.
And there's still a lot we just don't know about how to best harness this power.
So what are like some of the key challenges
Yeah.
that, researchers are working to overcome?
Yeah.
And what can we expect to see in the coming years?
Well, one of the big ones is scalability.
Okay.
Even though they're aiming for 1 million qubits,
Right.
we're still a long way from having quantum computers that can solve truly complex problems.
Right. It's like that house of cards analogy, right? Even if you build a really tall one,
Right.
slightest breeze, it
Exactly.
knocks it down.
Yep. And then there's the issue of error correction.
Right.
Qubits are incredibly fragile,
Yeah.
and even the tiniest errors can snowball into big problems
Right.
when you're dealing with these complex calculations.
So they're working on making the qubits more stable
Right.
and also developing ways to like correct errors before they become problems.
Exactly. And they're also working on developing new quantum algorithms
Oh, interesting.
that are specifically designed to run on these noisy, imperfect
Right.
quantum computers.
I see.
So it's a very active area of research,
Yeah.
and there's a lot of excitement around potential breakthroughs in the next few years.
It sounds like we're still in the early days of quantum computing,
We are.
but the progress being made is pretty remarkable.
It is. It is. And it's not just about the technology itself. It's about this potential to solve problems that were previously impossible,
Yeah.
to open up new avenues of exploration,
Yeah.
and just fundamentally change how we understand the world.
Well, I think we've covered a lot of ground in this first part of our deep dive,
We have.
but we're just getting started. There's so much more to explore with Majorana 1 and the quantum revolution it promises to usher in. But for now, we'll leave it there.
It's fascinating to think about how Majorana 1 could impact fields that are beyond the obvious ones we've talked about.
Yeah.
Like finance, for example.
Okay.
It relies so heavily on algorithms.
Right.
For things like risk assessment.
Right.
And those algorithms are only getting more complex.
Oh, absolutely. I mean, it's a data-driven world,
It is.
and that data is only getting bigger and bigger and more complex.
Right.
So I can only imagine, like, the advantage a quantum computer could give a financial institution.
Oh, yeah. We're talking about being able to analyze these massive amounts of data,
Right.
identify patterns that traditional computers would just miss completely,
Wow.
and make predictions
Yeah.
with a level of accuracy that's not possible today.
So like risk management,
Uh-huh.
fraud detection,
Yeah.
portfolio optimization,
Yeah,
all of that could become like exponentially more sophisticated.
exactly. And it's not just about making more money. It's
Right.
about making the whole financial system
Yeah.
more stable,
Right.
more efficient.
Wow. Imagine being able to predict and then potentially mitigate financial crises.
Right.
I mean, that's a thought-provoking idea. But let's circle back to those topological qubits for a second.
Okay.
We talk about the knot in a string analogy,
Right.
which I think is really helpful for
Yeah.
kind of visualizing this stability.
Mm-hmm.
But can we like dive a little deeper into why they're so much more robust than traditional qubits?
Sure. It all comes down to how the information is encoded,
Okay.
in a traditional qubit.
Yeah.
It's all about the quantum state of a single particle.
Okay.
And that's really delicate.
Right.
So any disturbance can mess that up, and that leads to errors.
Right.
It's like if you're trying to balance a coin on its edge,
Right.
the slightest nudge,
Yeah.
and it's over.
It's over. Yeah. It's like all your eggs in one basket.
Exactly.
Right.
But with a topological qubit,
Yeah.
the information isn't stored in the state of a single particle.
Okay.
It's encoded in this collective state of multiple particles that are arranged in a specific way.
Yeah.
So it's more like braiding several strands of hair together.
Okay.
Even if you tug on individual strands, the overall braid is going to stay intact.
Ah, so the information's kind of spread out, which makes it much harder to disrupt.
Exactly. And then you add in the fact that those Majorana particles are their own antiparticles.
Right.
So they exist in this kind of quantum superposition.
Right.
And you've got a recipe for a qubit that is incredibly resistant to noise.
Like they built them with multiple layers of redundancy.
Exactly. Yeah.
Making them much more fault tolerant.
Yeah. And this inherent stability
Yeah.
is what makes Majorana 1 so promising.
Right.
It potentially could overcome one of the biggest hurdles in quantum computing,
Yeah.
which is building systems that are both powerful and reliable.
Right. Because you need both.
You do. You do.
Okay, so we've talked about the hardware. What about the software? I mean, we touched on Microsoft's plan to integrate Majorana 1 into their Azure platform,
Right.
which I think is incredible. But how does that work?
Yeah.
How do you even program a quantum computer?
That's a great question. And you're right. It's not as simple as just coding on a classical computer.
Right.
Quantum programming requires this whole new way of thinking.
Right?
But that's where the power of cloud computing comes in.
Okay, so walk me through this. Let's say I'm a researcher. I'm working on, I don't know, developing a new catalyst to break down plastic waste.
Okay.
How would I, like, go about accessing and utilizing Majorana 1's power through the cloud?
Well, first of all, you wouldn't need to build your own quantum computer.
Right, because that would be incredibly expensive.
Yeah, incredibly
They're
expensive.
complex.
Exactly. Instead, you could access Majorana 1 remotely
Okay.
through Azure,
Okay.
just like you would access any other cloud-based service.
So kind of like renting time on a supercomputer, but it's a quantum supercomputer?
Exactly.
Okay.
And what's really great is that Microsoft is developing tools and platforms
Yeah.
that are specifically designed to make quantum programming
Yeah.
more accessible,
Right.
even for people who aren't quantum physics experts.
So even if I don't have a deep understanding of, like, quantum mechanics,
Right.
I could still potentially harness that power to tackle real-world problems?
That's the goal.
That's amazing.
Yeah, and this potential for democratizing access
Right.
to quantum computing is, what makes this technology so transformative.
Yeah.
We're not just talking about like a handful of elite institutions
Right.
or corporations having this power.
Yeah.
We're talking about potentially anyone with an internet connection
Right.
being able to tap into this.
That's a game changer. But even with cloud access and user-friendly tools, there's still going to be a learning curve, right?
Absolutely, there will be challenges.
Right, because it is a pretty specialized field.
It is, but the exciting thing is that, Microsoft's actively building this quantum ecosystem.
Oh, okay.
So they're partnering with universities, research institutions, even high schools
Wow.
to educate the next generation of quantum programmers.
So it's not just about building the hardware.
Right.
It's also about creating this community.
Yeah, a support system
Yeah.
around this new paradigm of computing.
Wow.
And platforms like Azure Quantum are going to play a big role in that.
Right.
They're not just providing access to the hardware,
Right.
but they're connecting people with experts,
Yeah.
creating opportunities for collaboration,
Right.
sharing knowledge, and really helping to drive the field forward as a whole.
It sounds like we're watching the birth of, like, a whole new industry
Yeah.
with all of its own, like, unique set of challenges and opportunities.
It is. But amidst all the excitement,
Yeah.
it's important to kind of acknowledge that there are still hurdles.
Oh, yeah, for sure.
Like one of the key challenges is improving the fidelity of qubits,
Okay.
which basically means making them more reliable,
Okay.
less prone to errors.
Okay, so even with topological qubits,
Yeah.
they're not completely immune to noise.
No, they're not.
And as we scale up to millions of qubits,
Right.
those errors can start to really add up.
They can. So researchers are exploring all these error correction techniques,
Oh, okay.
both on the hardware and software level.
Okay.
And they're also working on developing entirely new types of qubits
Wow.
that are even more robust,
Wow.
less susceptible to noise than topological qubits.
It sounds like a lot of research and development.
Oh, absolutely.
Still ahead, but the progress is really encouraging.
It is, and it's not just about the hardware, remember?
Right.
We also need to develop new algorithms
Right.
and software tools
Yeah.
that are specifically tailored to, the unique capabilities of quantum computers.
Right.
We're just beginning to, scratch the surface
Yeah.
of what's possible with quantum software.
Hmm.
And there's this vast, uncharted territory
Yeah.
waiting to be explored.
It's kind of like the early days of classical computing,
It is,
Right?
yeah.
when people were just starting to, like, glimpse the potential of
Exactly.
this whole new technology.
Yeah,
Who knows what we'll be able to achieve?
I know.
Once we unlock that full power.
It's so exciting.
It is. It is.
And it's not just about building faster computers.
Right.
It's about expanding the boundaries
Yeah.
of what we thought was possible.
Right, both in terms of, like, scientific understanding
Right.
and just technological advancement.
Exactly.
It's really about pushing the limits
It is.
of
Yeah.
human ingenuity
Yeah,
and creativity.
it is.
And speaking of pushing limits, there's another aspect of quantum computing that I find really intriguing,
Yeah.
and that's the potential philosophical implications.
Now we're getting into some deep territory.
We are. But you're right. I mean, if quantum computers can really achieve the kind of computational power
Right.
that's being predicted,
Yeah,
it raises some pretty profound questions, right?
it does.
About, like, the nature of reality,
Yeah.
consciousness,
Uh-huh.
even the limits of human knowledge.
Yeah.
I mean, could these machines potentially help us unlock some of the biggest mysteries of the universe?
That's a great question. It's certainly a possibility. Some physicists and philosophers believe that quantum computers could help us finally crack some of these enduring mysteries of quantum mechanics itself.
You mean like those bizarre phenomena like superposition and entanglement
Exactly, yeah.
that always seem to defy like our common sense understanding
Right, they do. They really do.
of the world? I mean, could quantum computers help us understand the true nature of these phenomena?
Yeah.
Could they give us insights into like the fundamental fabric of reality?
It's possible.
I mean, these are questions that have puzzled physicists
For decades.
for decades, yeah.
And quantum computers might hold the key.
Wow, that's a thought-provoking idea. It's like we're on the verge of this whole new era
Yeah.
of scientific exploration where we're not just observing the universe.
Right.
We're starting to understand its inner workings
Right. At the deepest level.
at the deepest level, yeah.
Yeah, it's really exciting. And it's not just theoretical physics.
Right?
Quantum computing could also have these profound implications for how we understand consciousness.
Oh, okay.
Some theories actually suggest that consciousness itself
Yeah.
might be a quantum phenomenon
Mm.
arising from these intricate quantum processes
Wow.
that are happening in the brain.
So you're saying we might be able to use quantum computers to simulate those processes
Potentially, yeah.
and potentially create like artificial consciousness.
It's a fascinating idea.
That is straight out of science fiction.
It is, it is. And, even if we don't achieve something as, ambitious as creating artificial consciousness,
Right.
the fact that we're even asking these questions,
Right.
that we're pushing the boundaries of knowledge in these profound ways,
Yeah.
is what makes this field so compelling.
It really does speak to that power of human curiosity,
It does.
that inherent desire to understand the universe and our place in it.
Yeah,
I mean, quantum computing isn't just a technological revolution.
right.
It's a philosophical one as well.
Well said. And as we continue to explore these frontiers of quantum computing,
Yeah.
who knows what other mind-blowing discoveries
Right.
and philosophical quandaries
Yeah,
await us. This is just the beginning of an incredible journey.
it is. Well, on that note, I think we're going to wrap up this part of our deep dive into Majorana 1 and this quantum revolution. But don't worry, we'll be back soon to delve into even more fascinating aspects of this groundbreaking technology. Stay tuned. It's amazing to think that just a few years ago,
I know.
a lot of what we're talking about today
Right.
was considered purely theoretical.
Yeah,
And now with Majorana 1 becoming a reality,
right.
we're seeing those theories start to like materialize
Yeah, it's
in the
true.
real world.
We're moving from like the realm of abstract concepts
Right.
to tangible applications.
Yeah.
And that's incredibly exciting.
It is. It really feels like we're standing at the edge of something
It does.
truly extraordinary.
Yeah,
And it's not just the technology itself, it's the potential impact.
right.
That is so fascinating.
It is.
I mean, we've talked about material science, medicine, energy, finance, AI.
Uh-huh.
The list just seems endless.
It's almost mind-boggling
It is.
to consider all the possibilities.
It is. We're witnessing the birth of a new era, I think,
Yeah,
where the boundaries of what's achievable
right.
are being completely redefined.
Yeah,
And it's not just about solving existing problems.
right.
It's about unlocking these new avenues
Yeah.
of exploration,
Yeah.
asking questions we couldn't even conceive of before.
Yeah, exactly.
I mean, who knows what mysteries will unravel, what wonders will create.
I know. It's so exciting.
It is. It is.
And one area I think where Majorana 1 could have a particularly profound impact
Yeah.
is space exploration.
Okay.
Imagine sending a quantum computer
Right.
on a deep space mission
Yeah.
capable of processing just vast amounts of data
Oh, wow.
and making really complex calculations in real time.
Wow. That would be a game changer.
Yeah,
I mean, we're already using AI to,
right.
analyze data from telescopes and rovers and all that.
Right, exact.
But a quantum computer
Yeah,
could take that to a whole new level.
it could.
What kind of things could we do with that power in space?
Well, for one, we could analyze astronomical data
All right.
with just unprecedented precision,
Right.
potentially discovering, new planets, stars, even entire galaxies.
Wow.
We could model complex astrophysical phenomena
Yeah.
like black holes and supernovae,
Yeah.
gaining a much deeper understanding of the universe.
So it's like having this super-powered scientific laboratory
Yeah,
orbiting the Earth
right.
or even traveling to other planets.
Exactly. And
Wow.
think about the search for extraterrestrial life.
Okay, yeah.
A quantum computer could analyze signals from space,
Right.
With incredible sensitivity,
Right.
potentially detecting patterns or anomalies
Hmm.
that we would just completely miss with our current technology.
Wow.
It could even help us decipher
Yeah.
complex alien communication
Right.
if we ever encounter it.
That's amazing. It's like something straight out of like a science fiction novel.
It is.
It is.
It really is.
But speaking of pushing boundaries,
Yeah.
let's talk about the impacts of Majorana 1 on cryptography.
Okay.
Quantum computers are often seen as this threat
They are.
to our current encryption methods.
All right.
But could they also be used to create new,
Uh-huh.
more secure systems?
That's a great point. And it's true
Yeah.
that quantum computers could potentially crack
Yeah.
many of the encryption algorithms that we rely on today
Oh, yeah.
to secure, online communications, financial
Right.
transactions, sensitive data, all of that.
It's a little scary, right? When
Yeah.
you think about it.
It is, but at the same time, quantum technology also opens up the possibility
Okay.
of new forms of cryptography,
Okay.
ones that are specifically designed to be resistant
Okay.
to quantum attacks.
So it's a double-edged sword.
It is,
right?
yeah.
It can break our existing codes, but it can also help us build
Right?
stronger ones.
Exactly.
It sounds like this cryptographic arms race.
It kind of is.
Yeah, that's interesting.
And that's why research in quantum cryptography
Yeah.
is so important.
Yeah.
We really need to stay ahead of the curve to
Right.
make sure that our digital world
Right.
remains secure as we enter this age of quantum computing.
It's a fascinating paradox.
It is.
This incredible technology that holds so much promise,
Yeah.
but also presents these significant challenges and
Yeah.
like opening a door to a whole new world.
It is.
But we need to be prepared for what we might find
We do.
on the other side.
Yeah.
So what does the future hold for Majorana 1? And for quantum computing in general? What are like the next steps? What can we expect to see in the coming years?
Well, Microsoft has a roadmap
Okay.
for scaling up Majorana 1
Okay.
with the goal of reaching 1,000,000 qubits
Wow.
on a single trip in the next few years.
Wow.
If they can achieve that,
Yeah,
it would be truly remarkable.
it would be.
And it would really accelerate progress in so many different fields.
Absolutely. And beyond just the hardware, I imagine we're going to see advancements in like quantum software
Oh,
and
yeah.
algorithms
Yeah.
and programming languages.
Absolutely. As more researchers and developers gain access to these resources through the cloud,
Yeah.
we can expect to see like a surge of
Yeah.
innovation
Yeah.
leading to breakthroughs we can only dream of today.
I know. It's so exciting.
It's a very dynamic field.
It is.
And I think we'll see some really transformative advancements in the years to come.
For sure.
The quantum revolution is just getting started.
It is. It is.
Yeah.
Well, as we wrap up our deep dive into Majorana 1 and this exciting world of quantum computing,
Right.
I want to leave our listeners with a final thought.
Okay.
The future of this technology isn't predetermined.
Right.
It's being shaped right now
It is.
by the decisions that we make,
Uh-huh.
the research that we do,
Right.
and the conversations that we have.
Exactly.
So let's engage with this technology
Yeah.
thoughtfully, ethically,
Yeah.
and with a sense of wonder,
I agree.
because it really does hold the potential to reshape our world
It
in
does.
some really profound ways.
It does.
And it's up to all of us to make sure that it's a future
Yeah.
that we can all be proud of.
Well said.
So thanks for joining us on this incredible journey.
Thanks for having me.